6, polynomials. So our first homework, we're gonna add and subtract polynomials, which we've done a bit of in class. So this should be more of a review. Polynomial expressions can be added and subtracted in order to visualize what happens when two polynomials are combined. Create a model of the addition problem below using algebra tiles. Sketch the model with the first polynomial above the second and find the sum. Then answer A through C. Okay, so we're just going to turn these two polynomials into algebra tiles. So we can say that x squared is like a big square. This is x squared, and we have two of them in that first polynomial. So this will be 2x squared. And we have 5 times x. X will be these more narrow blocks, these narrow rectangles. We got 5 of these. That is x, 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 x. I drew that one kind of short, my bad. And then we have minus 3. So minus 3 smaller ones. This is a -1, a -1, and a -1. I hope that's clear enough. And now we can add it to the second polynomial. And that one, we have one of these big x squared blocks. And we got -2x. So these narrow pieces have to be -x. This is -x. This is -x. And we have a +1. So this little square is a +1. All right, now when we add these up, we get, well, you know what? I'm supposed to copy this down again. We get 3 of these x squared blocks. Now 5 plus -2 is going to give us +3x. So we'll have 3 of these, which are x. X, x, x. And -3 plus +1 is going to give us -2. And we have -1 and -1 for these constants, these numbers that don't have variables. Okay, so that's just another way to add up polynomials, just so we can visualize it, so we can see it better, like we're playing with blocks. And record the sum of the polynomials. We got 3x squared plus 3x minus 2, or plus and -2, however you want to look at it. Okay, just like that. And describe what steps you took to add the polynomials. Well, we're all going to describe that a little bit differently, so I'll leave that up to you. And let's just go over some more vocab. Polynomials can be added by identifying like terms. We find the like terms and we add them or subtract them together, and adding the coefficient of the like terms. Remember, the coefficient is just the number in front of the variable, the number to the left of the variable. To be more specific, it's the number being multiplied by the variable. Coefficients. Describe how to identify like terms in the space below. Okay, you find terms with the same variable or the same base, same variable raised to the same power. Use the commutative and associative properties of addition. We can add polynomials by rearranging and grouping like terms. 2 methods are shown below. All right, horizontal method, I had this on the board before, but we could just put the like terms together. 5x squared is like terms with -2x squared. So we got 5x squared minus 2x squared. plus, we got 4x plus 3x. Notice how we're just grouping the like terms here. Same variables raised to the same power. And now we group the constants together, -7 minus 11. And we add these up, and what do we get? We get 3x squared plus 7x minus 18. And the vertical method, you're going to do the same thing. Well, you're going to add them in the same way, but we're going to stack them vertically, as the name says. Stack them vertically, one on top of the other. I personally think this way is faster right here. But we're all different. And minus 11. Okay, so now all we got to do is just add these together, and we're going to get the same answer. 3x squared plus 7x minus 18. Okay, so two different ways you can go about adding or subtracting your polynomials. Let's do a little bit more vocab here. Subtraction is the same as adding the inverse or opposite. So it's the same thing as adding the opposite number. For example, 5 minus 7 could be rewritten as 5 plus -7. When subtracting polynomials, rewrite the problem as an addition problem by adding the opposites of each term in the second polynomial. Okay, so last thing I'll do on this page here is just rewriting it. It's asking you to rewrite each subtraction problem as an addition problem. Do not solve, no problem there. Don't solve, just rewrite. So 8x plus 9 is the same thing as saying, 8x plus 9 minus 10x minus 6 is the same thing as saying 8x plus 9 plus, and we just change the signs on this. We go to opposite signs, -10x plus 6. Okay, and then I think with that you can solve this one in the same way. Change it to addition, change the signs of the second polynomial. Change the signs of each term in the second polynomial. So that's it for the handout, but let me just introduce the homework side of this. So right here, solve the problem on card A, draw a line from the arrow on card A to its solution in the top corner of a card in column 2. Okay, so we'll solve something over here, and then we're gonna see the solution somewhere in this top portion of one of these. So let's combine like terms here. We got x squared plus 2x squared is 3x squared. I cross them out. -6 plus +4 is -2x. 12 minus 10 is +2. So sorry, I should have wrote it down here. 3x squared minus 2x plus 2. Do we see that anywhere here? Oh, yep, that's our answer right there. So we can draw from here to here. And then we go ahead and solve this one here. All right, so this is the same thing as saying plus, negative. Okay, so this is negative 5x squared and that's a plus 7x, and that's a plus 9. Okay, I'm choosing to add these with the vertical method. So -4 plus -5 is -9x squared. Negative 11 plus positive 7x is negative 4x. And what's our last one here? 7 plus 9 is 16. Okay, and do we see that answer anywhere else? Yep, looks like right over here. And then we just continue on like so, okay? Get the answer and find the answer in the top portion, draw your arrows, and eventually you're gonna have some kind of pattern that I'll look at once you turn it in. All right, thank you, Ham class, good luck to you, and we'll see you next week.